So finally, guys, hello everyone. And warm welcome to all the new participants. Today I'm going to share my view on the topic of battery charging system. But my main agenda is to you make familiar with the Proteus software in circuit design, simulation, part and the visualization, which can increase your skill set. So in today's webinar, we will cover these subtopics: battery chargers, introduction of Proteus, about the Proteus software, AC to DC converter circuit, schematic diagram, about the how circuit design works, simulation part, PCB layout, how the 3D visualization will in real life, and battery charging status. So the battery charging status can show the SOC of the battery. So first question is about from my side, why we need a battery charging system and why we need the battery. So can anyone please explain why we need a battery? Can say it?
Respect the energy.
Yes, you are right. In our daily life, we use the battery in our surrounding on, like home appliances, to provide the backup power supply, just like we use the inverter power source. In solar power plant, we can store the charge electricity. And comes to about automobiles. Automobiles in which we have to provide the power supply to the auxiliary components like light, AC, blinkers, horn, etc. Let's move toward the low emission material. Low emission vehicles means electric vehicle. The electric vehicle is totally dependent upon the battery power source. So today we are going to about how the electric vehicle charge, and we will design one of the component of electric vehicle. So basically electrical vehicle charge on the two types of charging station: onboard charging station and off-board charging station. In onboard charging station, we will provide AC power to the substation. Then AC directly step down the voltage and pure AC is given to the vehicle, and vehicle itself convert AC into DC, and that DC power is used to charge the battery. Whereas the second charging station, off-board charging station, which is also called as the level 3 charging. In this, AC to DC converter function is done before to reach the car. So we will convert the AC power to DC power in the substation only, and then we will provide direct DC supply to the battery charger, which is also called as a fast charging system. So today we are going to design the onboard converter, which is AC to DC supply, which is used in several other equipments in the Proteus software. So it's about Proteus software. Proteus software is invented by the Lab Center Electronics, and the main function of the schematic capturing means you have to wiring diagram. You can easily import the microcontroller, and you can easily export the hex file of the microcontroller, and you can use easily. Just like for the project purpose, as you are doing, you can use it. PCB design. Whenever an electronic circuit is going to design, you can check that how much space is taken and what was the nanotechnology behind that. So to clear that pictorial representation in your mind, you can use this software and you can design that circuit in first the Proteus. And it also give a feature of 3D visualization, which is helpful for you. Basically, Proteus software is a tool used for the electronic circuit design and the simulation of PCB layout. And this software is widely used by the engineers, students for the designing and testing circuit before they are physically constructed. So it is pocket-friendly software, which is not you have to invest your money for trial the things or for a practically. So it is a better virtual platform which is helpful for us all. So this is a platform, this is a view of the Proteus web, Proteus, in which object selector is given. Object selector, where we have to select the objects and from where you can insert the object to this tool faces. So this is basically a blue color border is showing here, which is under the surface we can design the circuits. Run and simulation part is also there. In left side corner, you can see that play, pause, and stop button is showing. So it is used for the run simulation and editing windows where the introduction of Proteus is written itself, where we will design the circuit, label it circuit, and we can also see the simulation part in that place. We also getting a debugging and auto errors detection, which can help us to when we design the circuit, which help us to detect where I am, where my fault is there, and it can auto rectify your problem. So one of more basic thing that if you, in this Proteus software, we don't having a Arduino and microcontroller equipment, so you have to import it. Or you can take any equipments just like from registers, capacitor, inductor from the library file. Okay. So this is a schematic capture view. I am not telling about brief about, I can start the software part. So it's a schematic where we will design the circuits and we will check our outputs. So it's a PCB layout design. We can design that and we can check that how much space is taking and how efficient is it for us. And this is the picture of 3D visualization. From all the angle, left, right, and front view, top view, you can see and you can check that whatever the equipments or electronic components you used in the circuit is correctly placed. And next we will going to design the battery charging system. In the battery charging system, there are many functions, the over voltage cutoff, and to charge the battery, we having a label to show that how much battery is actually charged at the present and how much I want to charge, which can indicate us that our battery means SOC of the battery, it can show the state of charge of battery to us with the electronic configuration circuits. So basically today we are going to design the first converter part, and in the converter we will giving AC supply 230 volts and we will getting the output volt of 12 volt DC, which we will deliver to the battery charging system, which will indicate us that how much battery is charged after the duration of time. Hope you are getting interested. So this was the first window, which will, at the time of opening, we will see this. And from here, you can see that from my cursor, start. Here, open a project, which is already done by you. You can directly open from this place. New project, new flow chart, and the schematic diagram, which can be this only. So first we have to save the component name, and then we have to just click it. Now I will show you that the file name here, you can import the files. Here you can save your file or save as to Excel file, and you can also save for the print to how the circuit you want to print directly from the Proteus software. Editing part is given here. Your view, in the view of, you can change your dimensions and the cross-section parts of the circuits. After that, we have a tool, design, graph, debugging, error, library file, templates, which can use for the labeling purpose, systematic configuration we can check here. The best part of this, that the left side, all the equipments, all the tools are present in the left side, which is using to pick the components from just like ground supply, power supply, or we can use as a voltmeter, ammeter from here directly, which is like, I can show you the oscilloscope, CRO, which we call as CRO. We can directly show the display here. DC voltmeter, AC voltmeter, wattmeter, so which can, and one of the more important thing, that the pick from library, where from you can import the register capacitors. From P, you can add the capacitor of the any value. You can use it for our circuit design. So here the different types of capacitor which are having 0.47 microfarad, 33 microfarad, 2.2 microfarad, and you can choose the active cell which is used for the real life implementation. So we can use active components only. So let's move toward the AC to DC converter circuit, which we are going to design that. Here you can get, whenever you can drag the object or just click on the right click on the object, you can get you can easily rotate the components. You can packaging the tools to directly to the PCB layouts, and you can easily whatever you want to change the value. So you can change the values also from directly right click on the objects. So let's start with the doing AC to DC converter circuit, where we are going to design the AC signal, which is 230 volt, 50 hertz frequency, and we will convert them into 12 volt or 5 volt as per our the need. So for that, I have to first click the V supply, voltage supply of AC. We can say as a V sign. So voltage sign, I can directly import. It's added, showing in your object selector. Now again, I have to select the components. I need a transformer to step down the voltage. I selected the simple transformer. Again, I have to connect to make the rectifier bridge circuit or rectifier circuit full bridge circuit. So I need a diode. So the diode standard configuration number is IN4007. I select the diode and polarized capacitor, which the capacitor you directly can't connect to any polarity. In the polarized capacitor, the polarity is given. So you have to connect as per the plus minus symbol. Now again, I have to need a normal capacitor. capacitor of 0.1 microfarad. Here you can also see the architecturing diagram, which will show this diagram in your PCB. So I'm just clicking it. I'm getting all of the components. Now I need the voltage, fixed voltage supplier or voltage regulator. So maybe it's 7805. When I use the 7805, I will get the constant volt of 5 volt. And if I use the 7805, 7812, so I will get the fixed voltage of 12 volt. So you have to just click on the component and start placing it. Side by side, you can change your amplitude voltage and frequency. It's already fixed. So now move toward the transformer. Now I'm going to connect the diodes. So first I have to design the circuit I hope you will know about the half wave rectifier and the full wave rectifier. So I change my direction. This software provides us a free hand wiring connection, so it is very easy to connect. Now I connect the polarized capacitor. I choose the polarized capacitor of 417 nanofarad. I connect one more capacitor. Again, clockwise. Now I need to connect the voltage regulator. I will show you both 7805 and whatever the output we are getting from the output side. So I connected the V input pin number 1 to the input of the circuit, and second pin is connected for the ground. And from the third number pin, we will get the voltage output. So my circuit is ready. So let's start with the simulation part. But how can I show you? For that, I need a voltmeter. So I have to connect the DC voltmeter. DC voltmeter, just drag it. So let's start with the simulation part, and I think I will get 5 volt output. So you can see the screen that while you're running it, I will getting the 5 volt up. Or I can replace it with 78 1 2 because I need a 12-volt voltage. So let's simulate this also. Here I'm getting the 12-volt output. So my AC to DC converter is ready, which means that I'm giving a 230-volt of AC supply and I'm getting the output voltage of 12-volt DC output supply. Okay, this is okay. I have done mistake. I have added the AC voltmeter. So let's replace them. First, I have to stop the simulation part. DC voltmeter. Again, I start the simulation part. I'm getting the 12-volt voltage. So let's start with the PCB layout design. So otherwise, here you can see that diode and capacitor symbol is, you can design the circuit from there. You can go to the nearby that PCB layout design. So you can start with the PCB layout. You have to do the process in the schematic capture only, then only you can import here. So you have to just click to the schematic captures and you have to first do the packaging. So it can understand that it is architecturing structure and it can directly auto port it to PCB layouts. So for that, I need an input and output connections. So my two inputs and output, I have to add one pin junctions, pins. I need a 2-pin because 2 input and 2 output. So I will select the pin, 2 input and 2 output. So I delete the supply connection. I deleted the transformer and now I can connect my pins. Same as I need a second pin to get for the output connection. And now I'm starting the packaging. So start the packaging tools. In this interference, you can see that what was the dimension of your components. It's a register or PN pins. So it take a 2 mm space in your PCB layout. So I have to assign the package, Norcom, save. Like this, I have to simultaneously add all the equipments to the packaging tools. I forgot to delete the voltmeter, so I can delete this. And now the last component is junction P to packaging. After that, you have to reach the PCB layout, and first you have to go for the left corner border edge. So you have to draw the border of the circuit. So for that, you need a 2D box mode. And now I'm using the auto placer. If you have done anything mistake in your component selection, then the click part is not showing to that component. So whenever you are importing any of the component from schematic to PCB layout, so better to check that all the components are correctly packaged or imported to the PCB layout. Okay, so it's need a border edge, and again I have to go for so while zooming it, you can see that my circuit is directly imported to the PCB layout. Now you have to set the components according to your need. So now I will little bit arrange all the components. So I start with the diode, first diode, D1, then D2, D4, polarized capacitor, and I'm making the connections far away, which is properly understood by you. So these are my input junctions pin, and these are my output junctions pin. So I will connect this here. And these are the two capacitors which are connected to the circuits C1 and C2 and C3. So I've arranged all the components here, and now I have to just go for visualization mode and see that my PCBs in which I connected all the 4 diode and 2 capacitors in flip all this. And after that, you can soldering it or directly schematics PCBs. You can change or check from all the angles. I will show you one more thing that I need the LM3914 for the display driver. So now I'm adding the component LM3914 is used to display driver, means you get a frequency signal as per the power voltage. First of all, I cut all those. I directly show you that how the LM3 also is used to design for packaging, add the packaging, and then move toward the PCB layout, auto placer. Yes, okay. And I don't need this, I need only the PCB package.
Hello, sir. Yes, this is not visible.
Hello. Hello, now I am audible.
Yes, sir.
I'm connecting the yellow color light for the third one. Orange color. I forgot to connect it blue color, so I will connect the blue one. 1, 2, 3. Now I have to all the connect the one of the LEDs from positive power supply. Now I have to connect all the LEDs bulb with a 10 number pin, and according to that I have to connect all the pins of the one of the LED to the LM3914 driver. So I need to add some more components, battery, resistor, we need to take the pot, variable resistor. For that, I choose the active one. And I also need the push-pull button switch. So we have to connect the power supply V to the positive power supply of this, and we have to connect the negative power supply to the negative part. Wait a second, I will not take in a ground. Or to give power supply RLO to connect to ground number pin. And I have to connect VRO and VRH, bypass it. Now I'm placing my battery, which is 12 volt, and I can change the current using the so I have to connect the first. Resistance. And I have to connect this negative to the negative terminal, and I can connect the pot. In this pot, you can change the value easily from the left right arrow. And used to the pot of 4.5 kilowatt. I can change the value of resistor 2.7 kilo ohm. And in this one, I need a 3.5. So I need, okay, it's a 1 kilo ohm only. I need the 4.5 kilo ohm pot. Okay. I need to add the push button, and I have to connect with the mode to give the power supply for the switching purpose. Now my battery charging system is connected to is ready, but now I have to give the power supply plus volt to the LEDs also. So I'm replacing this junctions pin. I add this pin to power supply to the driver also and to the LEDs also. And the negative power supply is connected to the ground. So here my circuit is completed, and now I will start my circuit for the simulation purpose, and I'm checking that how much battery is charged in initial condition. Okay, I forgot to connect the adjacent. So now it's showing my battery is fully charged. Here you can see that it's a green light is glow. So now I set my circuit in complete zoom connections. Okay. So now I start my push button. And I will change my resistance value from here. It decreases all the now starting my simulation part again. While increasing my resistance, the light will glow. In this condition, when the electric current is after some time, the current should be more high. So the resistive flow can sense that, and it can provide the power supply as per our requirement, and it shows the indicating the battery, and or you can say that it shows the status of battery. So from the register port, variable port, you can easily change the value of variable. You can see that when I'm using to the low part, so the low current resistance can flow through the battery, and it shows that how much the battery is charged. So we can show that it's also a hardware form of SOC and state of charge. You can easily simulate it, and in real life, Proteus software is used for the electronic circuit projects and make the project cost efficient for the students and engineers, and less error due to schematic construction on the Proteus. So which is helpful for us only. So anyone having any questions or related to this? I'm stop sharing my screen. So anyone having any question or doubt related to how to import the circuit or design the PCB layout? Yes. Proteus is a free software. You can directly download from the Google. Get a PC. It's useful, and you can directly download it, and you can design your circuit. You can take the help of YouTube also for the installation purpose. And there are two types of Proteus is available in the Google. One is the demonstration part, and one was the professional part. In demonstration part, you will not able to save your files, but in professional part, you can save your files, whatever you are doing, the circuit, which can make your good portfolio also of yours, that whatever you have done in your engineering field, or which is useful for you. So any questions? Yes, you can design any circuit. Just you have to check that what are the components you are using. Is there any online course for learn Proteus software? Yes, you have an online course, or you can visit our site also. We will provide to guide you. Okay, I will please share me the site and platform to learn. There are many just like 𝗚𝗏𝗏 and the Multisim are the softwares which are provide a online platform to check the circuit or design any circuit. But Proteus provide more efficiently, like when we are connecting to the Proteus software, we can easily import the microcontroller, and which is easily to combination of, just like a microcontroller runs on the software part also and the hardware part also. So you can easily import the hex file, means a software code file, to the library function, and it is easy for us. How much cost of the course? So this question will, I hope our team will help you in this question. Okay, I will contact to our team or our ISIEINDIA certified webinar course, or you can visit the ISI course learning platform and you can ask for the course also. So it will help you for the Proteus guiding and the course also. Okay, this is from my side. Thank you, everyone.
Thank you, GH.
Any more questions anyone have? So they can ask, please. For the confirmation, anyone have any extra questions to be resolved? Certificate will be mailed in your mail account for the confirmation. Okay, hello everyone. This side Kashish from ISIEINDIA. I hope you all like the webinar and looking forward to enhance your skills in the same domain. So may I know some of your feedback? So raise your hand if you feel that the session was helpful for you. You can also comment yes or no. Okay, nice, and thank you everyone. So coming to our introductions, so I would like to introduce ISIEINDIA products, which will help you enhance your skills. Kindly watch a small video about ISIEINDIA courses.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, globally wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thank you everyone for watching the video. Hope you guys have understood the products. So any of you wants to enroll in the course or interested in the course, kindly send us the inquiry through a QR code displayed on your screen. So if you have any questions, you can ask here as well. Thank you.
If you are interested in course, please scan this QR code. If you are interested for a course inquiry call, then please scan this QR code. Our executive will call you.